I'm Tony Rice from productionscheduling.com. We develop planning and scheduling systems in Excel and teach others how to do it too. Here's a typical manufacturing company and the system they developed in Excel. PS Cycles are in Illinois. They had a patchwork of legacy systems, with planning and scheduling handled in Excel in a semi-manual way. They planned to replace all of this with a new integrated ERP system, including advanced planning and scheduling or advanced planning and optimization. Linda, the planning manager, was very excited about this. You see, she'd read Goldratt's Goal, and she could see how theory of constraints enabled by the new systems could reduce inventory while driving service levels up. The new system was implemented to replace the legacy systems, but when it came to the planning and scheduling, the implementation failed. Linda was very disappointed. You see, in common with many other companies, PS Cycles found the advanced systems to be very complex, leaving a gap that was too much for them to bridge. Written by PhDs for PhDs is the way Linda put it. There's nothing wrong with the software, but Linda's team could not handle the huge change involved. Then Linda found the training offered by productionscheduling.com, and with the help of a consultant, uplifted her team's Excel skills. They started by automating their existing processes and integrating with the new ERP system. Then they added functionality one step at a time to slowly close the gap. The ultimate goal is still to implement APS one day, but now the gap is very much smaller. Linda says that planning and scheduling is about getting answers to 10 questions. We buy, make, and send, and we need to know what to buy, make, and send, how many, and when. With distribution, there's an additional question, which is where to send it to. With Linda's Excel system, one click gives her the answers to all 10 questions. Let's look at the manufacturing process. They make ladies' bikes, men's bikes, and kids' bikes. They come in blue, maroon, and silver. The kids' bikes don't come in silver, so that makes 8 products altogether. They buy steel tube, cut it, shape it, and weld the tubes into frames. They are then painted in one of the 3 colours. Purchased component sets, wheels, pedals, brakes, etc., are assembled onto the painted frames to create the finished bikes, which are packed and sent to the distribution centre. The distribution centre replenishes inventory at the depots and dispatches directly to other customers against sales orders. Let's see how it works. As we know, material flows this way, but the data flows the other way around. Now let's look at the process. Demand consists of sales forecasts from the depots and sales orders that are over and above the forecasts. Supply is finished bikes at the DC and the depots, inventory and WIP of components at the factory, and purchase orders for components that have been placed with the suppliers. The first step is to look at the depot inventory and figure out what should be sent to the depots now so that they can meet their sales forecasts. When we figure out what will need to be sent later, we also consider sales orders because they may consume inventory. This sends a list of products to make to the MRP module, which explodes the bikes into subassemblies and components and nets off inventory and WIP. MRP determines what components to buy, and this is compared with purchase orders that we've already placed with the suppliers. It also determines what components to make, and we see if we have the capacity to do this. The capacity planning module says when the components will be required, so that the purchasing activity can be synchronized with the production schedule. How does this answer the 10 questions? The purchasing module answers the buy questions: capacity, make, and replenishment, send. Let's start with the sales forecasts. The depots send their forecasts to the factory, Excel files attached to emails. Dallas has the 8 products across the top with 6 months down the side. Chicago has the months across the top, products down the side, and subtotals. It doesn't matter that the depots have different formats. The system consolidates them all into one. When the forecasts are put together, we can make reports like this. You can see there's a huge spike in December, and it's mainly kids' bikes. The depots prepare the forecasts by month, but we want to do our replenishment calculations in weeks. Weeks are smaller and are the same length. Converting to weeks is not just a matter of dividing by 4 or 5. It recognizes that we do not sell on weekends or public holidays, and that some weeks span a month end. It also recognizes that sales tend to be higher at the end of the month. The inventory is compared with the forecasts to calculate what needs to be replenished according to these rules. For example, when the inventory of ladies' bikes in the Dallas depot drops to 1 week of cover, then they should receive a delivery from the DC that will take it up to 3 weeks of cover, allowing for the 2 days that it will take to get a consignment from Chicago to Dallas. This report shows the current inventory of each bike at each depot in weeks of cover. Red is below minimum, yellow is okay, and green is too high. It's mostly green, so you can see that generally PS Cycles is overstocked. A legacy of the old procedure when the depots used to place replenishment orders on the DC and compete with each other when products were scarce. Let's look at the inventory of men's blue bikes compared with the minimum and the maximum. 2 depots are below the minimum. Denver has a surplus, so we could replenish from there, but we would prefer to do it from the DC to bring the 2 depots up to the maximum. Now, what if there weren't enough men's blue bikes at the DC? The system calculates an average cover and rations the inventory so that each end up with the same cover. Back to the inventory cover report again. The bottom part of the report shows the cover after the depots have been replenished from the DC. You see, most of the red has gone away. Let's focus back on these two depots. There may be other bikes at the depots with low inventory. They are above the minimum but below the maximum. We'll be sending a truck to these depots, so we may as well top these up as well and make up a load and save on transport costs. Every day when the system runs, this report identifies the depots that have triggered a replenishment and lists top-up quantities as well. So, we've looked at replenishment rules, inventory rationing when there's not enough to go around, and topping up. We've looked at what needs to be replenished now, so let's look at replenishment for the rest of the horizon. Take ladies' blue bikes in Dallas, for example. The minimum is 1 week's cover and the maximum is 3. When this is translated into units, it goes up and down with the sales forecast. As they get sold, the inventory falls, and we can project that we will hit the minimum on September 9. At that time, we need to replenish to the maximum. These calculations carry on for 6 months. Of course, there are other bikes being sold, so the top-up principle applies to the projected calculations as well. Right now, we have $700,000 of inventory. If we stick to the replenishment rules, it should reduce to $300,000 in 3 months. But at the end of November, it'll shoot up again. This is the depots stocking up to cover the December rush. Now let's look at sales orders. Here is an order for 650 bikes due on August 25. This is over and above what's in the forecast. Right now, we have plenty of inventory, and by August 25, we project we'll have a surplus of 250 bikes. The order will soak up this surplus, and we only have to make 400 bikes to meet the order. The replenishment module generates a list of bikes to make. This would include the 147 ladies' blue bikes to replenish the Dallas depot on September 9, and the 400 men's maroon bikes for Euro Sports on August 25. This goes into the MRP module, which explodes through the bill of materials down to components and sub-assemblies and nets off inventory and work in progress. Let's see how this works. A men's silver bike is made of a silver frame plus a handlebar and saddle tube, which are made, and a cable set and component set which are purchased. The handlebar and saddle tube are cut from chrome tube. A silver frame is made of a frame, some paint and a front fork. Remember, a frame is made of 5 different lengths of tube plus a frame component set. There are the 5 lengths of tube, each cut from steel tubing. Let's trace through the MRP logic. We need 100 bikes and we don't have any in inventory, so we need to make them. Each bike has 1 handlebar, so we need 100 handlebars. But we have 80 in inventory, so we need to make 20. The next job. We have 25 saddle tubes, so we need to make 75. We have 45 silver frames, so we need to make 55. We need 100 cable sets, but we have 250 in inventory, so we don't need to buy any. And there will be 150 left for the next job. Component sets, we need to buy 48. A handlebar takes 550 millimeters of tube, so 20 will take 11 meters. We have 73 meters in inventory, so we don't need to buy any, and there'll be 62 meters left for the next job. A saddle tube is 200 millimeters long, so 75 will take 15 meters. We have the 62 meters left from the handlebars, and there'll be 47 meters left. The same calculations cascade all the way down through the bill of materials. We isolate all the items that we need to make and list them. And all the items we need to buy. But for most of these, there is nothing to buy because we have inventory, so we can ignore them. And list the rest. That's what we need to make and buy for 100 silver men's bikes. OK, that's how MRP comes up with what to make and what to buy. The list of what to make goes into capacity planning to see if we have the capacity to make everything. Let's look at capacity planning. We're going to look at exploding through the routing, then set up production, rough cut capacity, and finite scheduling. Here is the list of items to make. The finished bike will come off the assembly line. The silver frame comes off the paint line. The unpainted frames come out of the welding work centre. The handlebar is cut. And then shaped. In fact, every tube goes through 2 operations. So the 9 items we have to make will take 15 operations. That's exploding through the routing. Now let's look at setup production. When you ask the guys on the paint line, do you have the capacity to make all this stuff? They'll say, well, it depends on how many colour changes you want us to do. If we're on blue and we switch to maroon, it takes 20 minutes. But blue to silver takes an hour and a half. You see, you need to clean very thoroughly before spraying silver. The paint line supervisor would really like to paint enough blue frames for the next 6 months, but that's just not feasible. These are paint jobs going down the paint line. 18 jobs will take 14 colour changes. The first job is blue, so we look out, say, 20 hours of production time and identify all the blue jobs. Then the same for silver and maroon. And group like colours together. And the same for the next batch. That cuts down the changeovers from 14 to just 5. If the 20 hours was increased, it would reduce them still further, but that may damage due date performance. Let's focus on the first 4 blue jobs. They are for men's, ladies' and 2 kids' frames. Now, if the paint line wants to see them in this sequence, then the upstream operations, welding, tube shaping and cutting, will need to synchronize. For each frame, there are 5 lengths of tube plus a handlebar and a saddle tube. These are the tubes that will need to be cut. Within the blue batch again, setups can be reduced by putting like lengths of tube together. The paint line will spend 9% of the time on changeovers. That would be a problem if the paint line were the constraint. More on that later. That was setup reduction. Now let's talk about rough cut capacity. These are the parameters for each work center that determine capacity: the number and speed of the machines, the setup times, and when they take place. There is the 20 hours we spoke about, and each work center works to a shift calendar. Each shift calendar lists the begin and end of every working period, and looks ahead for about a year. It's edited to take out public holidays or to put in overtime if it's needed. There's a lot more detail than rough cut capacity needs, but the same calendars are used by finite scheduling as well. If we compare the hours we need with the hours we have over the next 6 months, then we should have roughly enough capacity. Welding is the most heavily loaded work center, so let's look at that more closely. Here is the load on welding by month, and it also shows how much of the load is because of sales orders. The load is over capacity for the last 3 months, so some of the work will have to be done earlier, in the first 3 months. Rough cut capacity planning has assured us that we should have enough capacity. Finite scheduling works in a lot more detail, and we'll look at that now. There's a blue job running on the paint line. It will finish at 7:13, when we can start setting up for a silver job which will run until 12:49, etc. The rule is the next job starts when the previous one ends. This is true of the paint line, but welding has more than one machine running at the same time. Machine 2 is available first, so job 3 goes there, and job 4 on machine 1. When job 4 finishes, machine 2 is still busy, so job 5 goes on machine 1, and job 6 there. The second rule of finite scheduling is the next job starts on the first available machine. We weld 100 bikes, and then we paint them. Wrong. When we have welded the first transfer batch of 20 bikes, they go to get painted, while the next 20 get welded, and so on. The next operation starts when the first transfer batch is complete. What if painting runs much faster than welding? Well, after every batch it'll have to wait. Although it's faster, you cannot finish painting until the last frame is welded. The rule is, the next operation can't end before the previous operation. It takes 5 different lengths of tube to make a frame. So welding is dependent on tube shaping for all 5 tubes, and the rule is an assembly can start when the first batch of the last component is complete. A batch of bikes will probably move through the factory something like this. So far, the logic we've used starts now and pushes out into the future. Well, what if the due date for these bikes is out here somewhere? We would start at the due date and work backwards to figure out when we need to start, using pull logic. The rule is, don't start before you have to. If the due date was earlier and we applied pull logic, we may find we would need to start in the past. Clearly, this isn't feasible, so we would push again and accept that we would miss the due date. The scheduling logic uses 3 passes: push, pull, and push again. Here is another illustration of what the 3-pass logic does. We start a batch of bikes, but when we get to the paint line, it is busy with another colour, so we have to wait. If we apply the principle of don't start before you have to, then we should also delay the upstream operations. Here is a Gantt chart from the system showing how a batch of 288 bikes will flow through the factory. They're to replenish the Los Angeles depot in week 43. This is a regular Excel pivot table, and we can select any sales order or replenishment order at the top. Here is a Gantt chart for the welding work center showing the frames to be welded on each machine each week. It's an Excel pivot table. So by double-clicking here, you can open it up into days. Double-click on men's frames, and it shows you the orders they're being made for. Double-click again, and it hides the detail. Click here to select another work center. And here is the Gantt chart for the paint line. Again, you can show the detail. This report shows the scheduled utilization of each work center. It's clear from this that welding is the constraint. Back to our 10 questions again. What, how many, and where remain the same. But when gets shuffled around by finite scheduling. As we saw earlier, we are over capacity in the last 3 months, and this shows how finite scheduling has moved the excess work to the first 3 months. We also saw how inventory would come down. But because bikes will be built early to meet the December demand, inventory will go up again in October and November. In December, it'll drop below the ideal level. Here are some sales orders that'll be late because capacity is tight. The first 3 are past due. Today is August 15, so they are already late. We measure the lateness content of our schedule in dollar days. That is, dollars of contribution or throughput times number of days late. A total of $11 million days. In isolation, that figure means very little, but if we plan to work overtime or add an extra welding machine, we can see how much the figure comes down. For depot sales, we anticipate that we will run out of some models in December, and that will have a bottom line impact of $33,000. That's the contribution or throughput on the lost sales. This is how many people we'll need to support the schedule. It peaks at 20. And this is our transport requirement. The trucking company gets a fresh one of these every week. So, we've looked at finite scheduling. Now let's focus on purchasing. MRP tells us what to buy. And makes a list like this. Capacity planning tells us when we need the components. The system compares this with the orders already placed on the suppliers and recommends actions. There are only 4 things you can do with a purchase order: place it, chase it, defer it, or cancel it. Take blue paint for example. We currently have inventory up here, and as we spray each batch of blue frames, it'll come down. If we're going to run out within the lead time plus a safety factor, then we need to place an order for delivery here, so that we don't run out. Each day when the system runs, it generates a list of orders to place. Often it's blank. Now, since placing the order, our consumption of blue paint has increased more than we planned. We need to chase that order to see if we can get it in earlier. Here's the daily list of orders to chase. If the converse is true, and we use a lot less paint than we planned, then we have an opportunity to defer or push out the order and save ourselves some cash flow. The orders that are going to be 6 and 7 days early we could probably leave, but 22 days, we could probably push that one out. Okay, that is place, chase and defer. If we project that we would still have some inventory at the end of 6 months, then maybe there are orders we can cancel. Now back to the orders to chase. The kids' component sets are there because we opened up a consignment and found they were the wrong ones. We have some more on order, but now we need them tomorrow. Purchasing have come back and said, sorry, but they're already on the water and we can't fly any more in from Japan any earlier. August 25 is the best we can do. The material constraint gets registered, and there's a feedback loop so that the production schedule shows that after we've used the component sets we have, we can't assemble any more kids' bikes for 10 days. PS Cycles built the whole thing in Excel without any programming. And now they get answers with just one click. When Thomas Edison developed the light bulb, he said, "I have successfully discovered 1,000 ways not to make a light bulb." Our fast Excel development methodology has been refined over a number of years, and on the way we discovered 1,000 ways not to build a planning and scheduling system. Our systems are in daily use by hundreds of manufacturing companies all over the world. These are the 16 e-learning modules that will teach you the skills you'll need to build planning and scheduling systems in Excel. And there is no programming. With the e-learning modules, you get the PS Cycle system. Your skills will enable you to adapt and modify the system to meet the needs of your own company. If you need help, we have experienced consultants at hand to help you. Who will benefit from our offering? Well, you'll need to be reasonably proficient at Excel. This is not an Excel beginner's course. Planners and schedulers who want to be in control of their own destinies, and supply chain consultants who would like to deliver fast, practical solutions to their clients without the cost of a package.